Okay, here's chapter 10. It's called Biodiversity and Valuation. And here we have a picture of a giant tree frog in Australia. And here is our chapter. Here's our frog. Here's our chapter. Biodiversity and Valuation. And let's define some terms. Biodiversity is a variety of ecosystem species and genetic differences within species. Biodiversity is critical to life. Um, and your author uses the red-tailed boa as an example. The loss of the red-tailed boa constrictor, may threaten the laughing falcon and other species above it in the food chain, but also dark rice-field mosquito. Wow, and other members of the insecta class because snakes help keep frog populations in check and thus help insect populations to survive. So here's some more pictures of, I think these are jellyfish, and there's a lovely little quote here. In nature's infinite book of secrecy, a little I can read. That's from William Shakespeare, Antony and Cleopatra. So from an anthropocentric viewpoint, I guess that's a mankind-centered viewpoint, biodiversity is important not only for the sustenance of the food chain atop which we sit, but for medicinal cures, fibers, petroleum substitutes, oh, we need those. Agents for the restoration of soil and water, natural beauty, tourism, pride, and education. Ooh, what do we got? Oh, exotic fruit in the tropics. So, biodiversity means fruits and vegetables, means exotic fruits and vegetables, not just what is in um, one location. And here we have a toucan in Mexico. So biodiversity is everywhere. Um, you know, and tourism depends upon biodiversity. Now, we economists have developed primarily anthropocentric techniques for estimating the value of biodiversity. We'll talk a little bit about these valuations in this chapter, and there are attempts, but of course they're imperfect measures as to the value of wildlife. The primary reason why they're imperfect is that we do not have great measures. The marketplace values maybe, let's say this toucan, for example, may value it as a pet, but not necessarily its value to the natural food chain as a whole. Okay, so biodiversity loss. Oh, there has been a lot of loss here. Estimates: total number of living species between 7 and 100 million. Wow, that is a big range there. And about 1.75 million species have been classified with Latin names. So, biodiversity is in a natural state of flux, and there's always new species emerging, some species becoming extinct, and there have been in the past, I don't know, 500 or so million years, 5 major extinctions, and a big extinction was, of course, the dinosaurs. I think that was in the Triassic period, 208 million years ago. 23% of families that were lost. Now, families is a scientific grouping for a class of species. Now, the sixth and current extinction phase is human control, and I guess this is called the quaternary um, um, spaces of extinction. Um, Scientists estimate that the present extinction rates of between 10 and 1,000 species a year are 100 to 10,000 times higher than the pre-human rates of extinction. And among the hardest hit so far are large mammals, birds, beetles, and amphibians. Okay. Now we're talking about global hotspots, and this is figure 10.1. Is that true in the 5th edition? Indeed, it is 10.1. And a hotspot is an area that has a large number of species living nowhere else, and so these are located in red. And there's 25 major hotspots holding 44% of plant species and 35% of vertebrate species. Your author lists all of them here, and he lists them in the 4th edition, but not necessarily in the 5th. Yeah, there's a lot here, so he's taken them out in the 5th edition. Now, one must consider land values along with biological data for effective cost-benefit calculation. This is cost-benefit with regard to preservation. Is it benefit? Does the benefit outweigh the cost if the area is in a high density, human density area? Great quote here. And this is an example of Brazil versus Chile. Brazil's Atlantic forest contains about 20,000 plant species and 1,300 vertebrate species, while central Chile contains 3,400 plant species and 335 vertebrate species. And this is the key quote. However, if land costs 10 times as much in the Atlantic forest as in central Chile, more species can be saved with a given expenditure by purchasing land for conservation in central Chile and in similar locations. So you can get more of a bang for your buck by being mindful of the land values, the land market values, that is. Very, very interesting. And and what is the most efficient use of money to preserve species given different land values? And your author says if all species were valued equally, an efficient policy would shift dollars to the location where the largest fraction of species could be saved per dollar until the savings per dollar were equalized across locations. So you save a bit more in the areas where the land values are cheap until that's equalized to the more expensive areas. Very, very interesting. And he further goes on to say, with diminishing marginal returns, the marginal benefit per dollar spent in the funded location will eventually fall in line with the marginal benefit of spending elsewhere. So it's not just these biodiverse areas; it's the land values equated with the biodiverse areas. That is the key as to where to use our scarce resources to preserve species. Very, very interesting. Okay, models of biodiversity, and that looks like I think that's a seahorse, and I saw a seahorse earlier this morning out in Kaneohebe, although that's a much more spectacular looking seahorse. Let's see. Oh, excuse me, it's a sea dragon, and is found only in Tasmania and along the southern coastline of Australia. So the slide is models of biodiversity loss. How do we humans affect it? And there are lots of ways. We fragment wilderness areas with roads. We drain wetlands for development. I assume that's real estate development. We introduce non-native species that become pests to wildlife. Oh my goodness, do we have examples of that here in Hawaii? I guess one of the one that is reached legend and lore is the mongoose. We clear forests. Oh, we most certainly do. We convert grasslands for agriculture or development. Oh my goodness, do we ever do that? We humans alter the global climate. Oh boy. We extract natural resources. Oh, that we do. An earlier chapter was all about energy and extracting oil and gas, and that certainly affects biodiversity. We emit air, water, light, and noise pollution, and we otherwise encroach on natural habitat. So we do have some means by which we are affecting the natural habitat. We affect biodiversity. Okay, this ends the first section. I think it will be of 3 sections for this chapter.